Okay. So because today's chapter was very short compared to previous chapters, I decided not to work with the notes. I guess you can see them in our permanent link. That's basically the notes that existed before I got started. So like just objectives about EDA and the data set and the log transformation, which I'll talk about more in just a second. But they have here like one more piece, like a slide, and it's a Shiny app which isn't active about like another city in the US where they have like house sales prices, like the Ames data set. So because it's such a lean both chapter and a notes, then I decided to just review the chapter itself. And I added a few more things. I'll show you guys in a few minutes. So what this chapter does, like in broad strokes, is basically introduce the Ames housing data set, which you know, and yeah, so that's basically it. It talks about like how you can access it, and how to load the data. And then it starts performing EDA, which is exploratory data analysis, and uses a histogram, which is, I think, the most basic plot to use when you're performing EDA on a numeric variable. So then they show how the sale prices vary across different scales, and what we see here is that the sale price, which is the horizontal variable or axis, is very much right skewed, meaning that we have most of the values of the sale prices are located to the left of the axis, and a few extreme outliers or extreme values to the right of the scale. Very small amount or very large sale prices, which in my experience, a lot of the time when we talk about prices as variables, then they would be right skewed, either prices or wages or things that have like some kind of financial value, where you go through different kind of scales or scales, I guess. So this major variable of sale price is right skewed, and then they use the very popular transformation of using a log transformation. And here we see not transforming the data itself, rather transforming the plot, or transforming the x-axis on a log 10 scale. Are you both familiar with the log and log transformations, or should I elaborate on it?
Yes, I think I'm familiar with it.
Okay, perfect.
I'm okay with it.
Okay, perfect. Because it's one of those things that if you're familiar with it, then it's like natural, and if you don't, then you don't understand what you're talking, like what we're talking about. So, and I just wanted to make sure. So that's the transformation, and after the transformation, the data is a little bit left skewed, sort of, but it's much better than the original variable before the transformation. So that's how they use it. And they also note here, which is important, that the disadvantages of the log transformation are mainly related to interpretation, like to understand how to interpret both predictions and metrics and so forth. Personally, that's one of the reasons that I prefer most of the time using log 10 transformation rather than log 2 transformation, because in log 10 transformations you could not always on metrics, but on predictions you can still have like a feeling on which kind of which scale are we talking about. Like if you have 3 point something after a log 10 transformation, then you know you're talking about something in the scale of the thousands, because it's 3 to the power of 10. Oh, sorry, 10 to the power of 3. Yeah. So so that's why I prefer mostly log 10 transformations, and that's what they also use here. After the transformation, sorry, yeah.
Can I have a question? So
yeah,
I also
course.
mostly use log 10 transformations. The reason is it's easier to interpret as well, because you just know 10 to the power of the results. But I'm just wondering, is there a difference between the log 2 versus log as base 10? It's like, will the result or the output significantly change, or maybe they will produce the same result, but maybe the digits will be off by a few decimal points?
Yeah, I think there is no difference, because the main like the heart of the transformation is turning from like a linear variable to a log transformed, and then it doesn't matter like on what base do you perform the transformation. But I think we can try it out here live if you would like to show both the differences. Would you want that?
Yeah, that would be cool.
Perfect. So I've prepared. I wanted to go to it like in the last piece of the session, but I think this is a perfect opportunity. Like a small script, like with a very basic EDA of the Ames dataset. So just start by loading the libraries, and gonna load Tidymodels and Tidymodels, which will give us the tools. And then using this, this data Ames, this means that we're loading the Ames data set here to our environment, which it exists inside the Tidymodels meta package. And then if we we can either view the data set here, or we can inspect its structure in the console here. We're not going to dive deep into that, but let's compare log 2 and log, oh, sorry, that's Hebrew. Okay, so we can compare those two transformations. This is, by the way, what we talked about, the new pipe operator, if you remember, which I mentioned. So this is how it looks, and we can plot it. Sale price plus geom histogram. And if we run this, then we'll get basically the same result as we've seen before, and then we can perform those transformations. So we can see the exact same thing, and then we add the transformation. Sorry, scale X. Oh, it's only log 10, don't have more options. Just a sec. Okay, I think
maybe you can do that within the mutates. So we can apply this.
One option is to use the mutate. I wanted to take the opportunity to introduce you guys the scales package. Are you familiar with it? Okay, so it's a really nice package. Just let me open okay. Like you can Google it up. It's a package. It's like a helper package for ggplot, and it also enables you to perform transformations. So I'll just see on this. Okay, I think. Oh wait, sorry. Scales it's only for the labels, I think. Yeah. So this one it won't help us. So we'll go with U's advice on mutating. So we'll call it SP, sales price, log 2, which is log 2 of sale price, and SP log 10 is log 10.
Sale price is a typo in line 12.
Typo. Where's the typo? Sorry.
Line 12 is your scale price, is sale price.
Oh yes, you're right. Thank you. So we'll perform the mutate, and then we can just like this. Okay, so this is the original variable. And when we show that's the log 2 scale, okay? And if we'll see the log 10 scale, I think it's supposed to be exactly the same, but only with different x-axis values. So let's see. That was the log 2, now the log 10. And yeah, okay, so you understand this is the exact same distribution, but only with different values for the variable itself. So the only difference is what you talked about, the interpretation difference. So like, do I use the power of like to the base of 2 or the base of 10? So thank you for your questions. It's something that I also used to wonder about. So, and this little exercise that we did here together is something that I did myself. I can't remember, somewhere in the past year, and found out about like myself. If we're here also in our script, then I wanted to show you just like, because this Ames dataset is going to go with us throughout the book, then I also put out some more variables here that I thought might be interesting, like exploring the relationships between different variables and the sale price variable. I used the untransformed variable because I think in a lot of cases, like for example, in scatter plots or box plots or whatever, then it's easier to understand the untransformed. Like, of course, for modeling, this something different, but for just the EDA itself, then I thought it might be better. So about a year built, we see that most houses in the data set are mostly new. I think 1990s and afterwards, it's interesting, this drop. Like I myself, I'm a policy data scientist, so for me it's interesting to see like we have this rise in houses built between 1950s and 1980s, I guess, and then a drop and then again a rise. So it's interesting if it has some kind of like, what are the reasons for this? Are these like social reasons or policy reasons, or just like specific data that like, I don't know, it only includes specific neighborhoods which were built in specific years or whatever?
I think it was more of a political reasons, because 1950s, that should be after the World War II, like 1945 onwards, 48. That's after the World War II, so most of the houses are built. Then 1980s was when, this is based on US data set, right? So 1980s, I think that they have a financial crisis after that for a while. There was like some civil unrest, then they have like some financial, like Great Depression. That's why I think that was a dip.
Yeah, I agree. Yeah, I agree. I think mostly, I think it was 1981 where the US like increased the interest rates like very, very sharply. I think the Federal Reserve, like the name of the head of the Federal Reserve was Paul Volcker, I think, Volcker, something like this. And like this rise in interest rates, so I guess it makes sense that it correlates with the sharp decrease in built houses. But very interesting, yeah. Condition-wise, we have the overall condition variable of the house, which is, you know what, we can flip it. It would be easier. Just a second. You know, chord flip. So just the data labels would be easier to read. So this makes sense, like that the better the condition of the house, the higher the price. And also, I think something that we can see here is like the value of using the untransformed version of the variable, because we can see, for example, like this increase, and like also the distribution within each category. For example, like the variance inside like average, which is much greater than inside like within other categories. So I thought that's interesting, but also it's like it makes sense. The better the condition, the higher the price. And I think most of my findings here are very trivial, I guess. When we look at a living area in square feet, because this is a continuous variable, then I showed it in a scatter plot, and we can see like this linear, or not necessarily linear, but correlation between sale price and the area of the house, which sorry, it's also interesting if this variable, like the living area, is also, maybe it also needs to have like this log transformation. It might also like go through different scales. When we inspect the number of rooms, then we also see like mostly like a positive correlation. The more rooms in the house, the higher the price. I think this is less interesting. And the same relationship exists with garage area. So the bigger the garage, then the pricier the house. Notice that I filtered out the houses without garage at all. If I keep it out, then when we run it, then you see like this like batch of houses, which like makes it harder or less intuitive to interpret the plot. So that's just for us, I guess, to get to know this Ames data set, if it's going to accompany us throughout the book. So I thought it might be interesting, and also an opportunity to help us understand this data set. Obviously, this is not the whole data set. If we have a look at it, we can see that we have 76 variables in the data set, which means, yeah, it's really rich. And we obviously won't go throughout each and every single variable and explore it and whatever. And this is where I hope the Tidymodels meta package and approach would come in handy, like how to use multiple, like how to handle multiple variables or predictors, like in a very short, in very little commands, like in a few lines. So this was May, or sorry, to address you as Mei Ling or May?
Yeah, either way is fine. Like
Either
May
way.
or Mei Ling is fine.
Okay, perfect. So as you suggested, like this is your question, it's what brought us here to this script. And then now I'll go back to the book itself. This is basically the whole thing of the chapter, like, or I think the most interesting pieces of the chapter. What we see here is a plot of the data self itself on a spatial map, and it shows the different neighborhoods of the data set. You can see here how or which neighborhoods are represented, and what's following is like some kind of very preliminary spatial exploratory data analysis, and they show all of these different examples. For example, this neighborhood, which is called Timberland, which is pretty much, you can see here in the like small kind of map here, which is pretty much isolated from the rest of the city. You can see an example of some kind of neighborhood within a neighborhood, which is also pretty much isolated to the most southeast part of the city. And also it's interesting that it's a case of a neighborhood within a neighborhood. More examples they show here is some kind of maybe imperfections in the data, where you have like this these houses which should be part of like houses that are tagged as Somerset and are shown within the Northridge neighborhood, and also vice versa. For example, this house, which is tagged as Northridge, but it looks like it's part of the Somerset. So it shows us the importance of performing a preliminary EDA. And this is also an example of like a small batch of houses which is far away from the other houses in the neighborhood. So this is basically the chapter. Also, because I never use or I haven't used yet spatial modeling or spatial data analysis or spatial data visualization, then I wanted to hop into the code where they created these plots, where they used here. So this is here in the it's like within that's the GitHub repo of Tidymodels, and within it, that's the repo of the book itself. And within the book repo, they have an extras folder, and within it, this is the file. It's an R script where they create these spatial plots, and they use the SF library, which I know it exists, but I'm not familiar with. And the place where they create the main plot, it's here. So this is the code. Some things I'm familiar with here. I think the main thing that the main code of line of code is this geom SF. It's like a ggplot geom object, but using this geom SF rather than a geom point. And you have to, as an aesthetic, you have to give it this kind of geometry argument. So as I said, I'm not really familiar with how to perform these operations, but I thought it might be interesting to step into the under the hood, I guess, and to see how they created these plots, because it's not something shown in the book itself. So this is another thing that I wanted to show you. And finally, on a concluding note, I wanted to share with you that they really lately released the latest version of the Tidymodels meta package, and we're reading the book about how to use Tidymodels, so I thought it might be interesting. Within this is the Tidymodels website, not the book, but the website where you have all the references and manuals and whatever. And if you want to read about latest news about Tidymodels, then you can read about it in the Tidyverse blog, where they have this tag of Tidymodels. And if we will open it up, we'll see that they released just 4 days ago this blog post, Q1 digest. Okay, and inside it, they here they have this latest news about the Tidymodels. The main improvements they had is one, more informative errors. For example, just a second. If they used to have the error noting the inside backend function, that's where the error was sourced, then now it presents the user facing function. For example, if you had an error with the degree function, then now it would be shown as follows. The second main improvement is that Tidymodels is becoming faster, and they had under the hood improvements of some kind of functions and workflows where it became 10-fold, 20-fold faster. And this is, they have links here to 2 different or separate blog posts where they write about it more elaborately. And also, I think this, after learning the Tidymodels framework, this might be helpful for us writing performant code with Tidy tools. Personally, I'm not that familiar yet with Tidymodels, so I don't think I could benefit right now from it, but in the future, this might be very helpful. I read this blog post when it was released about being faster. I didn't really understand what's going on like under the hood really, but I was impressed with the plots they produced. This is like showing that on smaller data sets, these algorithms, they were able to create like 20 folds or 10 folds improvements on like smaller data sets. That's the parsing package on a few prediction algorithms, logistic regression, decision tree, and booster tree. So I'm not, as I said, I'm not that an expert of machine learning and what are the specifics of each of these algorithms, but I was impressed by this plot where it shows like they did actually gain a significant improvement in performance. So that's basically it. I just wanted to share it. Like, I thought it would be interesting to look at how this Tidymodels framework is like a live thing, and it's like changing and gaining more capabilities throughout reading this book. And also the last thing is that this is a very long list of all of the specific packages within the Tidymodels meta package, where they introduced releases to each of these specific packages. So that's it. Do you have any questions or notes or suggestions or whatever?
No, but thanks for the lots of the informations. But I haven't been using Tidymodels because I've been using like smaller, my data set is quite small. But I find interesting, like just now when you were like sharing the news, it has a section on the PCA, the principal component analysis.
Yeah.
So that's kind of the analysis that I do run. So I realized that they mentioned that the processing time will be cut down by at least like a lot faster. So I'm not sure how much faster it will be, but that will definitely be very helpful. Like, because currently if I have to run it, it takes quite a while to run it because you have to calculate the dimensions for each component. You will see how that's the aim of learning Tidymodels. Hopefully you can cut down the processing time and calculation time. But thank you for sharing.
Yeah, thank you. So how long is the calculation time right now for you for the PCA?
PCA, it really depends, because just before running PCA, just like the pre-processing, like looking at exploring the data, looking at the distributions, I have to analyze each of the rows. So it usually takes me like 1 day just to set up the workflow. Maybe it should be faster, I think, for those who are very familiar with it. But just to explore the data, then thinking about it, and then just run it, I think it will take me like the whole day, like the whole working day, just to set up the workflow.
Yeah, but that's like, I guess, like a coding time.
Yeah, like coding time. And also if I just run it, like the rows for PCA, usually I have, let's say we need about 500 participants and each participant's 100 over rows. So that would take, I think, about few minutes, I think about 20 plus minutes. And that's not considered long. Like for me, like 20 minutes is like something like bearable. Yeah, like, but it's still quite long because you cannot get the instant result.
Yeah, it's not
instant gratification. Yeah.
Yeah.
But that's not the longest one. I think for mixed modeling, it will even take even longer. That's why I'm curious to explore like how Tidymodels can help me to do mixed modeling. Because like mixed modeling, bootstrapping, those are the ones that like computationally expensive. It takes out a lot of the time just to let the program run, and like you wouldn't want to do anything else while it's running.
Yeah, of course. Okay, so thank you, very interesting. Personally, I haven't had the chance to perform PCA on a in the wild, I guess, like on real cases, but I just read about it. So thank you for sharing. I wasn't aware that it might take so long. So thank you. Ulu, do you have any more notes or ideas or questions or suggestions?
For now, I don't have any question. I think thank you very much also for presenting the chapter. So I think I'll prepare, but for next week, I think we do not have anybody that is signed up for next week.
So what do you think about, my suggestion is that I'll write like this kind of invitation for more people to join. I will also tag Federica, so she'll be part of the discussion.
Okay.
And then we'll communicate through the Slack channel to see if we meet next week, or yes or no, and if so, who would present the chapter.
Okay, there is no problem. I think that is a good suggestion. I think I will be presenting after next week.
Okay.
Okay, so like 2 weeks from now, you're saying?
Yes,
Yeah.
yes, I will be presenting.
Okay, so perfect. So I'll send this invitation and I'll tag you guys, and feel free to add your point of view. Yeah, and we'll be in touch.
All right. Thanks for presenting today. Thank you.
Okay.
Bye.
Okay,
Thank you so much. Have a good day. Bye-bye.